This video is about telescoping series or telescopic series. A telescoping series is a series whose partial sums eventually only have a fixed number of terms after you cancel a bunch of other stuff out. So for this problem, how we're going to demonstrate what happens in these types of series is we're going to evaluate the limit of this as we go to infinity, but we're going to take some partial sums. So partial sums are just what happens if I only plug in the first term, or only plug in the first and the second term, or only plug in the first, second, and third numbers for x, or n in this case. So if I'm looking at this, I would have 1 plus 3 and 1 plus 4. So this first one would be 1/4 minus 1/5. Then the second one, I still have to plug in n equals 1, so I have 1/4 minus 1/5. And then the second thing that I would have to do is I'd plug in n equals 2, so I have plus 1/5 minus 1/6. So what you're going to notice is that these things cancel out, and so I would end up with 1/4 minus 1/6. And I could simplify these using I could simplify these things by getting common denominators and things, but I'm not going to do that just because we're trying to actually see something occur here. So the third partial sum, 1/4 minus 1/5, plus 1/5 minus 1/6, plus 1/6 minus 1/7. And so the 1/5 cancel, the 1/6 cancel, and you get 1/4 minus 1/7. And you may be able to see what's going to happen here. I now have 1/4 minus 1/5, plus 1/5 minus 1/6, plus 1/6 minus 1/7, plus 1/7 minus 1/8, and I end up with 1/4 minus 1/8. And so what I would do is I see all of these things canceling out, and that's kind of what I end up with. So if, for example, I have s sub 10, let's say, I'd have 1/4 minus, well, 1 had a 5th, 2 had a 6th, 3 had a 7th, so it looks like I would just add 4 to whatever this is, so it'd be 1/4 minus a 14th. So what if I have s sub 1,000? That would be 1/4 minus 1/1,004. What you're noticing is that this 1/4 doesn't change, and this gets super small. So what happens as I take the limit of this as n goes to infinity? The limit of this as n goes to infinity is actually what is really happening as I plug in infinity. What am I going to get? Well, I would get 1/4 minus 1 over basically infinity, right? And 1 over infinity is 0 for all intents and purposes. So what happens as I take the limit of this? Well, the limit as n goes to infinity of the sum of n equals 1 to infinity of 1 over n plus 3 minus 1 over n plus 4, that is just equal to 1/4. So now let's use a similar tactic to try and do this one. So if I take the first partial sum, I'd end up with 1/2 minus 1 over 2 to the 2 squared, which would be 1/4. So s sub 2 would be 1/2 minus 1/4 plus 1/4 minus 1/8. These would cancel off, and I would get 1/2 minus 1/8. S sub 3 is 1/2 minus 1/4 plus 1/4 minus 1/8 plus 1/8 minus 1/16. And notice that I would have 1/2 minus 1/16. All the middle things cancel off. And then the other thing that I'm going to notice is that this thing keeps getting small, and it basically goes towards 0. As n goes to infinity, this term goes to 0. So what is going to be the limit as n goes to infinity of the sum of n equals 1 to infinity of 1 over 2 to the n minus 1 over 2 to the n plus 1, that is 1/2. You can also use partial fraction decomposition to find sums in this. So what we're going to do is we're going to show that this sum is convergent, and we're going to find its sum by using partial fraction decomposition first. So 1 over n times n plus 1, I have a over n plus b over n plus 1. And then after I simplify this, I would have an plus a plus bn, that equals 1. So a plus b has to equal 0, just like in the partial fraction video. A equals 1, which means b equals -1. So what I would do is I would have a over n minus, 1 over n, because a was 1. So 1 over n minus 1 over n plus 1. I just replaced a and b. And then I have the sum from n equals 1 to infinity of this. And then I would have an expression for the nth partial sum. So what I would do here is s sub 1 was 1 minus 1/2. S sub 2 is 1 minus 1/2 plus 1/2 minus 1/3. The 1/2s cancel, so I have that. And then s sub n would be 1 minus 1 over n. What happens when I take the limit as n goes to infinity of this thing? I would just get 1. So this, I'm going to get 1 as my final answer. Now, maybe I probably should have written it a little bit more explicitly here. So what is s sub n in this problem? It would be 1/2 minus 1 over 2 to the n plus 1. And then in this problem, s sub n is 1/4 minus 1 over n plus 4. So in each of these cases, when I plug in s sub n, that would be what I would end up getting. And then as I take the limit of this, I would get 1/4. Or in this problem, I would get 1/2. Or in this problem, I would get 1. So then, one more thing that we might have to be aware of is, what if you have a problem that looks something like this? So the sum n equals 3 to infinity of, let's say, 1 over n minus 2 minus 1 over n minus 4. Actually, I'll put the 4 up here, the 2 back here, and I'll make this n bigger because I would have big problems down here if I made it that small. So let's start at n equals 6. So in this case, the first partial sum would be 1/2 minus 1/4. Second partial sum is 1/2 minus 1/4 plus 1/3, minus 1/5. Notice nothing's canceled out yet. So then I have 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6. So I finally have one thing that's canceling out. Then s sub 4, 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6 plus 1/5 minus 1/7. So now let's look at what we have canceling. We have a 1/4 canceling and a 1/5 canceling. Then let's continue. 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6 plus 1/5 minus 1/7 plus a sixth minus an eighth. So notice that the fourths cancel, the fifths cancel, and the sixths cancel. And then we can continue. I'll do one more just to kind of see what's happening. So 1/2 minus a fourth plus a third minus a fifth plus a fourth minus a sixth plus a fifth minus a seventh plus a sixth minus an eighth plus a seventh minus a ninth. So this 1/4 cancels with this 1/4. This negative 1/5 cancels with that positive 1/5. This minus 1/7 cancels with that positive 1/7. This plus 1/6 cancels with this. And so what appears to be happening right now is as we continue to go and go and go, this 1/2 and this 1/3 are staying. The 1/4 and 1/5 canceled, and then it appears that everything appears to be canceling with the thing 3 things after it after that. So 1/5 cancels with the thing 3 things after it, 1/6, 1/7, and so what's happening is this 1/8 is going to then cancel with, if I continued, the next 1/8, and then the 1/9 would cancel with the thing 3 things after it, and so on. The only things that never cancel out are these 1/2 and 1/3. So in this case, I can't just take the first term, because if you noticed in the first 3 problems that we did, we always just took the first term and that was the answer. Well, that's procedurally not legal to do. You have to actually understand what's happening. You can't always just take the first term. So in this one, the final answer, S sub n, 1/2 plus a third, and then as we cancel all this other stuff out, we end up with minus 1 over n plus 2 and minus 1 over n plus 3. Notice that those are the things that are kind of left over here. So as I take the limit of this, as n goes to infinity of S sub n, these would go to 0, and I'd have 1/2 plus a third, which is 3/6 plus 2/6, which would be 5/6. So my answer in this case would be 5/6.